Chapter 8 is finding confidence intervals, and so we're going to start here with 8.1. If it asks for a critical value, there is an easy place to find it if the value that you're looking for is listed there, and if it's not, I'll show you how to find that. So find the critical value needed to construct a confidence interval with a level of 82%. Um, there's a whole PDF of tables that is accessible from the Connect Math, and it's usually linked to in any problem that might need it. Um, if you don't already have a similar table, this one is in either the Dropbox or the SharePoint, wherever those files are right now. And if you don't know what I'm talking about, just ask me for it and I'll send it to you. So table A.3 on page A8 of this PDF is something we're going to be using later for t-distributions, but down at the bottom of it is this handy little confidence level thing. And so in this case, we're looking for 82%. If we had been looking for any, the confidence interval with any of these numbers here, and like 95% is a really common one, then the critical value would just be the number directly above it on the Z row of this table. But in this particular case, it is asking for 82%, which is not on that table. And so what we would do in the calculator then is go back to that second VARS inverse norm, and then it ends up being like the calculation where you had to find the z values and you were given the center number. So that was way back in 7.1. And there's a couple different ways to do this. I've got a calculation here that works, but there's a way that's, I think, easier to remember. So in that one where we did center, we would draw out that whole normal curve and block off 82% as being in the center. And that means the other 18% is split between the two tails, so that means it's 9% in each tail. So if we put our area here as 9% or 0.09, and then let's see, mean and standard deviation stays 0 and 1 because this is like a standard normal type of situation. And then paste and enter. We get the problem with doing it this way is you get a negative number and you want the positive value, and that's because we found the left tail and we really want the right tail. So, but it makes it easier to calculate. So it kind of depends on the student and what's easier for them is to get this, and then they have to remember to enter it as a positive value, not as a negative, or they can go through this whole thing and take what essentially ends up being the 0.09 plus the 0.82, and that would give us the upper bound, and then the area would be correct. So you can do that, figure out the 0.09 the same way, plus the 0.82, and you can put it all in like that on that line. You don't have to calculate it separately. And then it gives you the positive 1.34. So just depends on which one of those is easier for a given student to remember. But about half the time, the number that they give you in a problem like this is on that table, and that is the easiest way to do it. Okay, so then these we get to find, oh, the margin of error, and then you're just using this formula. There's not any kind of calculator shortcut for doing that. And so critical value, you're going to find that. And these at this point, the critical values are pretty much always, I think always actually going to be available from the table, so they don't have to do that. So critical value from the table, standard deviation will be given, and sample size will be given. So that's just a plugging it into this equation. And then they ask things like, if you made this change, would the margin of error be larger or smaller? And that goes on through the whole thing. But when you get to the construct a confidence interval and you've given all these stats here, then there is a particular function in the calculator for doing that. And now we're back to doing stat, but now instead of calc, we're going to do tests for the first time. And it is z interval. And to do confidence interval. Usually for the first ones, we're going to use stats. I'll show you one down the line for when we would use data, but whichever one looks dark is the one that you're using. So if you needed to, if it was on data and you had to switch to stats, you would arrow over and then hit enter and then arrow down and make sure that stats is what shows up highlighted with the dark background and the white letters. And so now we're going to find all the different things to fill in here. So we need the standard deviation, and that all this stuff is just going to be given in here. You just have to know where to put them. So standard deviation is 5.4. The mean, sample mean, is 36.31. N is your sample size, 74. And C level is confidence level, and that just has to be converted from a percent to a decimal. So 98% is 0.98, like I conveniently already have here. And then when I calculate, it gives me, the answer is this part up here in parentheses. It gives me the lower limit and the upper limit of the confidence interval, and that's exactly how they want it entered here. So you'd put in the 34.85 in the left box and the 37.77 in the right box. This one, the follow-on question is, if it weren't normal, would the confidence interval be valid? And in this case, you would say yes. And again, it's because the sample size is more than 30. So it's okay to use a assumption of normality as long as the sample size is more than 30. So then we've got, again, calculating the margin of error. Constructing the confidence interval is going to be the same for all of these, and then various things, are they going to be higher or lower if you change one thing about them. And so that is pretty much how it goes from here on out. Nothing new or different in any of them until we get to the ones where it gives you data instead of a mean and standard deviation, if it gives you a list of numbers. So in that case, what we're going to do is, rather than the stats, we're going to use data, but first we have to enter the data. And so just like we did at the beginning, we go into edit, and then if you have anything in there, arrow up and clear and clear. Actually, I'm just going to leave these numbers in here just so that I have something entered in here. And it doesn't matter that those numbers are wrong. So now stat back over to tests and z-interval again. And now we want to have data highlighted. So now you'll see that it's still giving us the standard deviation, and that's because we've got a sample, but we know what the population standard deviation is of the corresponding population to our sample. And this is what is going to be different in 8.1 versus 8.2. So I'll be talking about that next. The list is L1. It's wherever you put your numbers, and it's going to always default to L1. And then again, you're going to put the confidence level in here as a decimal. These, it's going to give you sometimes a few other questions. You have to check whether it's normal. That's because the sample size is less than 30. They'll give you a dot plot, or maybe you'll have to make a dot plot, but generally not. And then you just look at that, and pretty much the answer is always yes, that it's reasonable to assume that it's approximately normal. And that is because if it wasn't approximately normal, you wouldn't be able to continue with the problem. And so I don't recall having seen a situation where they give you all this and then you say, no, it's not normal, because then you can't actually do the calculation that it was all leading up to. So 98 again here, calculate. Nothing else about this is different. It's just that you're going to enter the data manually into L1 and then change to data and before you calculate, and then you've got your lower and upper limit of your confidence interval right here, just like in the other case. So that's the only variation in these. Then, if you're asked to find the sample size, it's just rearranging the same equation as margin of error. I usually give people the rearranged equation because they get a little lost with that square root thing and having to square the other side. So then once they've got this, again, it's critical value from the table, standard deviation, you're given the margin of error. But the thing that is weird in this one, weird or different or whatever, is they want the sample size needed, and when you calculate this, you're inevitably going to end up with some number with something with a decimal. So like say for this one, I ended up with 541.2, even though normally 0.2 would be rounded down to 541. In this case, any amount of a decimal is always going to have to be rounded up to the next biggest number, and that is because your sample size, if your sample size is even like a fraction too small, then your margin of error will be a tiny bit larger than you actually wanted it to be. So in these, the correct answer always comes from rounding up, no matter what is after the decimal point. So that's a little tricky thing to look out for. And that's it for this. It's another sample size, but nothing changes there. So that's all of section 8.1.